Hi and welcome back to the lab. And today here on the bench we have ICOM IC-765, and the 765 here came in because it was smoking. So during transmission suddenly it starts smoking, and the old man was a little bit confused, of course, and he switched off everything, and he didn't try it anymore because yeah, so that is his baby, and therefore we have it here right on the bench, and let's see what has happened and if we can help. Okay, and here we have our 765, and of course we need to check it finally, and therefore of course it is connected to AC, and well, we try to switch it on. He told me that he has a little problem with the switch, so that is known for this radio. So and what I can see is that it is switching in, right? But I'm feeding the LSB signal into the radio, and as you can hear, there is nothing. But basically having the radio switched in means that our power converter, which produces 13.8 volt, is working. But what I also see is that the radio for the moment is consuming 45 watt, and 45 watt is a little bit too low, because in our specification we see that it should consume about 75 watt. So that means that some circuit inside seems to be without power. So therefore one voltage regulator maybe, or such, may have blown up and went up in smoke, and that is what we now need to investigate a little bit more. Okay, so radio is cracked open, and what we are looking at is the top side of our radio, and here we see the regulator unit, what is at least a switching mode power supply, and we can say it is an inside external power supply, if you like. So we could take this unit completely out, and we could then supply our radio from outside with this unit, because when you're following the leads here, you see that we are going, let me go a little bit closer maybe. So you see we go in here with 230 volt in Europe, or 110 in the US, and then the radio is delivering, not the radio, the power supply is delivering 13.8 volts, and this 13.8 volts gets delivered to the different PCBs, and on the different PCBs we have our individually little power supplies, or voltage regulators, or DC-DC converters, or what have we. So fact is that we can test this unit here by simply testing the output power, and I believe that this 13.8 volt is fine, simply due to the fact that our menu is operable, our display is showing up, we can hear static from the speaker, and so forth and so forth. So simply let's do that first check. Okay, so the test leads are here in our socket, and now let me switch on the radio. Let's see. Yeah, perfect. So we see 13.7 volt, and that means that is fine. So we hear the static in the speaker, and that is telling us that our power supply, our regulator unit, is fine. Okay, question is now how to go ahead. I mean, we know that something has burned and there was smoke, so that means somewhere we need to find burning marks. And secondly, we should be able to smell something. So I flipped the unit over and well, I would say something is smelling here in this area, but when I look over the PCB, everything is fine. I mean, we have down here a voltage regulator, but the regulator is what I've checked, and it is delivering. It's approximately 8 volt, so that seems not to be our problem. Okay, down here is the NBVR unit, which is a kind of voltage distributor, and so if it is smelling here in this area a little bit, let's see what it is supplying. And beneath here our main unit, we have here our RF unit, and the NBVR unit is supplying with our 14 volt from our power supply, the regulator unit is supplying here our RF unit. And the funniest thing is, when I was looking around, I mean, he was shielding over, so I have taken that off, so that is the shielding. And when I was watching around here, look what we have here. So that here is a little cap, a capacitor, a titanium capacitor, which obviously burned off and made a short. So what we want to check now is if our power, our voltage, which comes here into our RF unit, is still present or not. Okay, so let's have a short look here on our NBVR unit, and you see that that we have here a socket with 5 14 volt outputs, if you like. So you see here our 14 volt coming into this NBVR unit, and the 14 volt obviously gets distributed here over this socket, and this socket here is delivering also a 14 volt to our RF unit. And what we see here is a portion of our RF unit, and you see here our J1. So there we get our 14 volts in, and you see here we have our C204, which is our little titanium capacitor, 4.7 microfarad by the way, which shorted out and was blown. So that here was obviously producing a short, and then it burned out. So that is what obviously has happened, and I'm now curious if this 14 volt are still there. So I've tested if there is maybe here from this pin a short to ground, and that is not. So that means our capacitor is completely burned out, so it is not any longer making a short to ground. So we can test here our pin and see if our 14 volt is there. Okay, and down here on the board, once again, to see where we are. Down here we have our shorted out capacitor, and our J1 here on the board is this guy here. Okay, so that is our J1, And the third pin here, let me see, that is not in focus, though maybe that way. So the third pin here, this one, should be our 14 volt coming from our distributor. And let's see if that is there. So I will go down here, so that way, but let me reposition the camera that we see our voltmeter. Okay, so let's check if we can see both. So first of all, I switch our radio on, of course, and now let me go down here to our test point, which is this here, and you see there is absolutely nothing, so we do not get here our 14 volt. But let me check, there must be another 8 volt receive voltage, so that should be 8 volt. It is 7.3 as you can see, so one socket is still getting, as you see, voltage a little bit too low, but our 11 volt is definitely not present here, and that already is telling a lot. And once again, where have we tested? So here our 14 volt, so that is not present, and that is not any longer shooting out. And what we have tested as well is our receive 8 volt, which is present, a little bit reduced. So maybe that there is something we first can see when we get here our 14 volt back. So that of course will be now our next step. And as we already discussed, we have here our distributor, and that is delivering on one pin. I do not really know which one, but on one pin it will deliver the 14 volt to the RF board. So let's go down here to the MBVR unit, and let's check here this J204. Okay, that way you see where we are. So here's our power supply, and down here is our MBVR unit. And now when I zoom in a little bit, you see very nicely this here is our 14 volt coming from our power supply, and this here is our distributor connector. And what we need to do is really to check each lead, because only one is the one which is going over to the RF board, and in theory minimum one of these leads should not deliver 14 volts, and that is what we need to check now. Okay, a little bit difficult to do both. So I switch on the radio now, so that is switched on, and I go down to the distribution connector we have already discussed. Oh no, first this is the red wire which I've shown you, and oh, I should put on my ground, of course. Without ground I cannot read nothing. Okay, so now again, okay, so here we have our 13.6, and now I go down to the distributor. So that is the first pin, fine. Second pin, fine. Third pin, oh, third pin is down. Okay, fourth pin, which is this here, is 13.5, and the fifth is 13.5 as well. And we do have one pin, this one, which is not delivering our 13.6 or 14 volts, so that is what is written here in the schematic. So that is not delivering the needed 14 volt, and that's the reason why the RF board gets not supplied. Okay, and when we look here at our connector, so it seems to be obvious what I suspect, and I guess you too, because we have, of course, here, oh, you can't see that, let's see. We have here our 14 volt. That is what we have seen. And we have our 14 volt on 4 pins, but not on the third one. And look, we have here a little coil and another filter on the board, and I think that simply due to the fact that the capacitor shorted out, this coil or this little filter here is blown, and that's the reason why it will not distribute the 14 volt to our RF board. That means we need to get our NBVR unit out. Okay, and what we already know is that our NBVR unit is here on the front panel, so it is in our front panel, if you like. So these switches here are on this unit, and that is really a pain in the back, because I really need to dismantle here everything to get down to this unit. So that is the disadvantage with older radios. It is sometimes very time consuming to go down to the respected PCBs to work on them. So yeah, let me see how we get to that PCB at least. Okay, so ICOM was friendly enough to make here the front detachable here from the radio, so that it is a little bit easier to get access to what is behind. But still, so that is our connector here, right? And there the connector is normally sitting, right? Still, I'm not able to get this PCB out, because we have our two switches also here on this board, and it really looks like that it is that there are screws from the front chassis holding finally this PCB by the look of it, and that means I still need to take off our front. Okay, and you see here our front is off, and that is not plastic, so that is really heavy. Yeah, some kind of metal, so really heavy. So that is still a radio of quality. Anyway, so our PCB is behind this, and that means we need to open this screws here, and we need to take off this holder, and then I hope that we can pull it out. Okay, so now I've loosened everything I can. So let's see if it will work now. Can I get this out of the way? Yes, so let's see. Ah, it's moving. Yeah, very nice. Very nice. Here it is. Oh my goodness. So I need to flip it over, so 1 second. Okay, so I was able to flip the PCB over, and yeah, so what we are looking for is for our L, or better say for both L's, and well, what I can see here on the board, I believe that this both here, this L, it is marked as L2, and here L1, so that most likely these both are responsible. So let me see it here from the other side, and we recognize that our third pin was dead, and when I following along here to this joint and flip it over, it looks like that it is this here, right, which is going to our third pin, so we can see it here, and that is going here to the L2, and the L2, which is here, is connected here. So this is our input voltage, and you see that is going here to this point, over to here, then here, here, and to our pin 3, which is that. So that means, very easy, I've switched my meter to continuity. Hope you can hear it. And I test now here from plus to our coil, that there, and then so that is in front of the coil and behind. Okay, so let me test from here to here to here. So that means from here to our output pin it is fine, but here, that is dead. Our L2 is dead, and that's the reason why we do not get our voltage. And that is this guy here. This guy is high resistance or open. So that needs to get replaced. Okay, according to our schematic, it is a 47 microhenry type here. But I cannot exactly say what the maximum rated ampage is through this component. So I think the best way is I have here, as you can see, 100 microfarad, and I put 2 in parallel, and then we make sure that the new coil holds the needed amps which are going through, and I think that's the best idea, so then it will work. Okay, so then let's see that we can get it out. Okie-do. Looks good. Should be already fine, I hope. Yeah. So here we have our defective one out, and now let's prepare to get our new one in. Okay, our new component here is in, and now we can test if everything was successful. Okay, testing now here from our supply, so from our red lead, right, to the third point here, which is this, should now be fine. And it is. So that means everything is honky donkey. Okay, so our boat is back in, so I hope that everything is fine. And that means the first what I'm interested in is if we have now here at this connector our needed 13.5 or yeah, something around that volt, and therefore let me see that I can get here my meter into the picture. Okay, so first let me switch in the voltage, and now let's see here our red wire, and yes, so 13.5 volt is now back. Here we should have our 872, that is what we have here, but definitely here our 13.5 volt is back. But of course we are not ready by far, so we really need to take care here on our little sucker. So that means we really need to take here our complete RF board out in order to replace here a new capacitor in. Okay, so unfortunately I cannot detach every single wire here from our PCB, simply because some of them are soldered in, and yeah. So okay, but I hope I can flip it over. Yeah, okay, so that should be sufficient to what we need to do. And our little capacitor, yeah, really yes, our little capacitor is exactly here under this ground spring here. Yeah, maybe I can, I can bend it a little bit, so that is not so difficult. And finally, yeah, I really can reach the both points here, the solder points, to be able to take the old capacitor out. Yeah, and here we have our burned out capacitor. So from this side it is even easier to see that is a titanium capacitor, and interesting enough it is telling us 10 microfarad, and I think I've seen in our manual we had 4.7, so I double check it, and then we're gonna replace it, of course. Okay, sure enough, you know, schematic it is 4.7, but I think it's even better to put back a 10 microfarad, so that is what I will do, of course. Here, funny enough, the old and faulty capacitor, which I have here connected to the meter, right? So it's still showing 13.5 microfarad. So we can put it back, no problem. Okay, so that means that it shorted out very shortly and destroyed the power line. But then, yeah, it's fine. Okay, so anyways, I will replace it here with a new one. So that is a 10 microfarad as well. And additionally to that, it is 30.5 volt type, whereby the faulty one here is only 16 volt. And normally it is not a good idea to put a tantalum capacitor, even back in the years, with so close added voltage rating into a power supply line. So that is only 16 volt, and yeah, it is known, especially in the past, that those capacitors, especially in power lines, will blow once in a while. So I increase now the voltage, and of course the new one here is a more modern type, which is more robust, so that will work out. Oh wow, and good that I double checked it. I've grabbed the wrong one. So that here is a 35 volt type, which now goes here into our circuit. Okay, so let's see how we can manage it around the camera. Okido. Let's see. Not good because I cannot really see it, but yeah, it's fine after all. And here is our new beauty in, so we can go ahead. Okay, everything is back together and our generator is switched in and connected to the radio. Everything is prepared, so let's test if it will work again. So let me switch the radio in. Okay, so you see 3.75 megahertz, 80 meter band, so the generator is set to the same frequency. We are on LSB, but apart from the fact that here our pot is a little bit dirty, we do not have receive. So there is obviously something additional wrong. Let me double check here our 13 volt on the RF board, and you see 13.5, so that is fantastic. So our repair we have done is so far fine, but there's still a problem. And I do have an idea. So you may remember when we tested on the RF board, I recognized that the receive voltage was a little bit low, so it dropped down. And that might be an indication for a collapsing power, not power, voltage regulator. So the voltage regulator we have down here is a guy who is responsible to supply here our main board and of course a portion of our RF board. And we have already seen that something was a little bit odd. So let us check this guy, because maybe this was already dying. Okay, and that you have a better overview, we use this meter here, so no problem. So let's check here the input voltage, which should be our 14 volt 13.6, so that is fine. And at the input of the regulator we should see approximately the same, and we do. And at the output, let's see what we have. What? Hello? Oh, come on. So obviously 0.9 volt. Obviously we have here a problem with our regulator. Okay, that means we need to take our board out in order to not really first replace it. I just wanted to know what's really going on, because we have seen the voltage drop, and it may that there is somewhere a higher current consumption, so that we have somewhere something wrong on the board at least. So it must not be subsequently the voltage regulator. But yeah, let us look after that, and then we decide how we go ahead. Okay, so I've taken out here our regulator, so that is our 8 volt regulator, and I've put in simply 2 wires which I now can connect to my power supply to get a better overview what the power consumption is, right? So that is very important to evaluate if there is another short here on the board, which is of course possible, and I can exactly see how much current gets drawn. So that is very, very important. And we have 2 options. First option is that of course here our regulator is faulty, so that is the first one. The second one is that there is somewhere a component which is drawing current, and that might then be possible to that we find it with our infrared cam. So let's go and let's see what's going on here. Okay, everything is prepared for testing. So let me first switch on the radio, and that all looks normal. So we have a display and everything, And now let me switch in here my 8 volt. Ah, okay. So that is working, and important to see is that we have 222 milliamps which get drawn. So that is what a voltage regulator like the one we have taken out is able to handle. So it does not look like that there is overload or such. So, but still there is no receive, and that still makes me wonder, because there must be another problem still. Okay, and what we are looking at here is the PLL circuit, PLL and the VCOs and DDS and such. Since we do not have a signal or a receive signal, let me call it that way, but all voltage is back, we have to look for another problem. And the first what I wanted to check is if our local oscillator is there. So in this case our LO1, right? And that is a configuration, so I'm picking here down there I am picking here you know, the signal, and I'm trying to build it here on the spectrum analyzer. Well, what you see is that there is only noise but no signal, and there should be a signal of about 54 megahertz, because that is what the oscillator needs to generate in order to be able to convert a signal of 14200 megahertz, which is the receiver set to, right? So that means that is the, what is it now, the third or the fourth problem what we have. Okay, so let's see why we do not have any output from our local oscillator. And now I'm picking here our LO2, so that is what we got from that point, and LO2 is also dead, both is dead. So then I have tested here the incoming voltage, and that is down here, the red wire. So we have our 13.5 volt, and we have here on the board 2 voltage regulators, and both voltage regulators do not deliver it required voltage. So we have one 5 and one 8, and both have no input power. And yeah, what has happened now here on our LO board? So look here, we have here our input, right, 14 volt, and that is present, and then we have here 2 voltage regulators, and both have almost nothing, half of a volt maybe, at their inputs, and so it is only normal that we do not have output voltage. And of course that is the reason why our local oscillators are not working. The question here is why? Hangs that all together with you know, our burned out capacitor, what was really making a hard short to ground? I don't know, but maybe. So maybe it was really a hard stroke, and it happened here and there more than only the capacitor we found, and our little coil which was burned out. So let's see why we do not get these needed voltages. Yeah, that really is all funny enough. I mean, we have tested this way, and there is no continuity, and well, it is because of this little resistor of 2.2 ohm. So that is a kind of fuse resistor, and when we go down to the board, you see this little resistor down here, and this resistor is open, or minimum very high resistor, 2.2 mech or even more. So that thing is really burned out. Okay, so we have to take it apart and replace this resistor and hope that then we have all faults out of the radio. So look here, that is the resistor out of the radio, and you see high resistance. So when we take here a new one, just to compare it, that is a 2.2 ohm resistor, and you see 2.168 ohm, and yeah, that is the one which is now going into the radio, and I'm very curious if that will work then. Alright, so our PLL board is back in, and the new resistor is in down here, right? Can you see it? But you know where it is. Anyways, okay, so everything is prepared. So now let's see if it will work. Right, so camera in a better position. Now, first I have to switch on AC. And now I need to switch on my power supply, where we feed here a voltage in for the main board. Ha ha! Look here! It's working! So S-meter is there and signal is there. Everything perfect. Absolutely perfect. Where is my speaker? Yeah. See? Working. Excellent. Excellent. Let me go over to the meter. So look here. Very, very clean signal. 41 dB SINAT or SINAT. And we are feeding in, so that is what we have over there. Almost minus 73. And that is really great. But of course we are not ready with the radio, so here we have to put back our shielding, which I will do right now, and then of course we have to replace here our voltage regulator, and of course that will be next. And of course we not only start with a new component, so we also start with new insulation material, so glimmer, and here this through insulator. Okay, so our new voltage regulator is in, and everything is nice, also temperature wise, so that is completely okay. So the old one was collapsing and was getting quite hot. So yeah, that was what we have seen, that the voltage it was producing, what we have tested at our RF unit, was already too low, and that was a clear indication that, you know, it was a dying component. And now I can leave here my fingers without any problem, and when I go over here to the tester, right, so we have a nice and clear signal. You see that our SINAT is crisp and clear, so everything is running like new. Okay, since we have now our receive back and everything is fine, of course now we need to check our transmit as well. So let me connect here the microphone to the unit like so, and let's see, we reduce here a little bit our output level, not to overdrive the tester. And let me see what's going on here. 1 2 1 2 1 2 1 2 1 2 1 2. Oh, that is not good. So I see that is switching here to transmit, but I do not see output power. So let me increase here output power. Nope, nothing, absolutely nothing. Microphone is up. Okay, let me simply switch here to FM. So let's see, yeah, it has switched to FM. What's on? No, nothing at all. Wow. Okay, so I've changed a little bit our test setup, just to make sure that there's really nothing, and PTT 1 2 1 2 1 2. So you see our wattmeter is not even moving a bit, so there is absolutely nothing at the output. Okay, so let me check if our spectrum analyzer is able to see something. So let's check here. 1 2 1 2 1 2. Ah, okay, so there we can see a carrier. And we have our marker at 14.201, so that is right. So you can see the data right in the upper right side of the screen. There, over here, you can see the frequency, and we see that the marker coming up. So let me put it off max hold. Okay, so that's a signal. What we see is it is on the right frequency, and what we can see as well, it is at minus 50 dBm approximately. So, and we should see 50 dBm plus, because plus 50 dBm is equal to 100 watt output power, and so we have a difference of 100 dB, which is huge, which is really huge. So something is obviously wrong, you know, and the point here is a little bit how hangs it all together. I mean, okay, we can explain for ourselves the burnt out tantalum capacitor, and we can understand that the little coil which we needed to replace is more or less logical. Yeah, a little bit funny it is that our voltage regulator is collapsing. So how hangs that together? Not 100% sure. Focusing on our burnt out tantalum capacitor, because that was obviously where the hit came in. So why our voltage regulator is defective at the same time is a little bit in question. Why? And now what's going on with our power amplifier, or what's going on with our TX pass? Wow, so the only thing is I really would start on again our ARF board, because on the ARF board we had the problem with the capacitor, and so we always should start thinking where we had the original problem, and maybe that a second component on our RF board is faulty as well. So maybe we were a little bit too quick in here putting back our shielding. So yeah, we have to take it away once again. So theoretically we should see here at this port, which is J8, our outgoing signal towards our power amplifier. So here we have already our, in our case, 14.200 megahertz signal, so that should be present because it is directly delivering it to our power amplifier and filter board and antenna switching board and what have we. So that is the first point to look what's going on. Okay, so I've here built my test setup. So I'm picking here as a signal going here through my HF test hat and going from there into the scope. So first of all, let me see, and I've switched it to FM that we do not need a tone. So let me see, so you see down there minus 50, it is a little bit bouncing back and forth, but when I press here my PTT, you see it is minus 30. So from the feeling, I would say it might be 10 dB too low, but well, it always depends on the architecture of our radio. Some will work with minus 30 here from our RF board, others have minus 10 or so to drive finally the power amplifier stage. So minus 30 dBm could be fine. So therefore I would assume that we do not really have a problem here on our board, on our RF board. The same is we see exactly the same here when I press my PTT, so you clearly see the signal. Let me see if we can go here a little bit closer to what we have, and you cannot really see it. Okay, yeah, now it is 14.200, so that is definitely the right frequency, the carrier frequency from FM, so that is completely right. And our test result down there, sorry, I have some reflections here which are really not very nice. It is hard to display, but even there we have 6.4 millivolt, and the scope is set to 50 ohm resistor, and 6.4 is corresponding to approximately minus 31 dBm. So everything is fine, and I mean it is good to see that we get our right frequency, because that is telling me that our PLL and everything is working fine. So there must be a problem with the pass through or over our power amplifier towards the output filter and antenna switches and such. So we need to investigate that pass more in detail. So the next what I'm doing, I'm feeding my power amplifier directly with my signal generator signal, and you see that it is set to minus 25 dBm, which is already 5 dB stronger than what we have seen at the output of our RF stage. And you see that the generator is set to 14.2 megahertz. And yeah, this signal is now directly fed to our power amplifier. That is what you see here, right? So that is our wiring here directly to our PA. And now when I press my PTT, let's see, yeah, I cannot see nothing. I mean, we see our signal there, all right? And I'm really feeding the amplifier now, and you see there is nothing here on the LP500. And I mean, we should see something, but now we have to go the signal pass over our power amplifier and so forth. Okay, so that is our power amplifier, and I've tested around all the voltages, and most of the voltages are fine except our transmit 8. So transmit 8 should, as the voltage is called, T8, so should have 8 volt, or let's say 7.99, whatever. But here in this case, let us check. Okay, so we should see almost everything. So let's grab here my probe. And let's go down to that test joint, which is a little bit hard to reach. So I hope. So that is a pain with the old radios. Okay, maybe I'm now on the test point. Let's see. And yeah, I am. So what you see is that our transmit is only 4.5 volt and it should be 8 volt. So what's wrong here with our transmit 8? So okay, the transmit 8 gets produced on the main board. Is there maybe another problem on the main board? Question mark? Yeah, funny enough, we are back here on the main board. So here's our regulator, which we have replaced, and here we have our TX switch. So that is TX8, and that means that we should read here our voltages. The transistor gets fed here by this resistor down here. Not sure if you can completely see it. This guy here. So that is a resistor, and over the resistor our transistor here gets 13.8 volt. And yeah, let's check our test results. Okay, so as already discussed, down here at the resistor we see our 13.6 volt, which is right. On the other side of our resistor we see almost nothing, or it is nothing what we can see here. So it looks like that the resistor here is open. I mean, it's only a 10 ohm resistor. And funny enough is here at this is the distributor here, and here we should see our TX8, and now when I press PTT you see exactly here our 4.5 volts. So that is corresponding with what we have seen at our power amplifier. So even the 4.5 volt is very, very odd, and additional to that, why do we have here another problem which it really looks to me that this resistor is open, and that means we have to take off once again our mainboard to see what's really going on there. Okay, so I've flipped over the board, and I've insulated here a little bit that it cannot touch here ground and shorting down. Anyways, so when I now testing here, as discussed, input of the resistor and output of the resistor, both is 13.6 volt, so that was a test error, because I was obviously not able to get completely to the joint. But on the other hand, if I go here to our output and I press PTT, you again see 4.8 volt instead of the needed 8 volt. And now where we know that obviously here the transistor is most likely working, it can be a load which is pulling down our 8 volt to approximate the half. So we need to find where this can be. Yeah, and we found another problem here in our TX on voltage, which only comes up when we pressed PTT, and we have here a Q6 down there, and of course I've taken it out because I was checking this circuitry around our TX up voltage, if you like, and there I found a faulty transistor, the Q6, and you clearly can see it here on the schematic. Our Q7 is our power transistor for TX, right, 8 volt approximately, and here that is our Q6, and the Q6 is switching the TX voltage in and out, and that transistor here is faulty, but it is not entirely faulty. So let me show you what we found. Okay, we have here our little transistor in, and now let me press start here, and the testing process starts, and here we have it. So we only have 2 diodes, which are not even rebuilding an NPN type, right? So that would be an PNP type if we consider that 2 is our base, which is wrong. It is not pin 2 which was the base, pin 1 was the base, by the way. Anyways, so we clearly see we have here a faulty switching transistor, and of course if we have a faulty switching transistor, our TX voltage, which should be approximately 8 volt, and we only have found it at 4.5 volt, so that is definitely one problem. And now we need to replace this little transistor, and yeah, let's see if that will cure our takes PTT takes voltage, or if there is still another problem. So you see, it's really becoming more and more a rabbit hole here. Okay, so as discussed, we have now replaced the faulty transistor. So here's a new one. We put here a higher graded cap in, so that is a 105 degree C capacitor, and we replaced a little resistor. So actually those 3 parts over there, so that is what we replaced here in our power supply, right? Good. So let's see if this now made any changes to our TX voltage. Okay, so first let me switch in the radio, which is here, and okay, we hear the static. That is good. And now let me go over here to our receive voltage, which is here 7.7, so that is good. So no change. Let me test the temperature. It feels good. Now let me go over to a test point for our transmit voltage, and we see 81 milliamps, but we know we have to press PTT first, so let me do that. 7.3, marvelous, that is good. Okay, so we know our TX voltage is back, so that was a problem, at least a little transistor. Now let's see, do we have output power? Okay, so that is the situation here. You see our radio prepared. So here is our microphone. So let's see what we can do. 1, 2, 1, 2. Wow. Hey, so maybe you can see it a little bit better if we do it this way. Once again. 1, 2, 1, 2. Audio. Audio. Is that good? Very, very nice. So that was the problem. So you've seen we really have 5 problems to fix. We had 4 problems on our receiver, and we had 1 problem on our TX side. So 5 problems in total, and all in different areas. Oof, I hope that this repair job is now finished, because you know that is a kind of I don't know, but it's working great. Okay, and once again we are testing here the receiver. So receiver is switched in, and you see we really have a clean and crisp sine with 44 dB sine, which is really great. And well, on the other hand, we're gonna check now the transmit as well. So therefore, let me go up here. So on the left hand you see our frequency. Let me turn it down here a little bit, the receiver tone. Okay, so you see we are feeding in with -73, but that are only the receive parameters. So we are interested now here all together in the transmitter once again, and I've reduced the output power a little bit because my test set is not able to handle 100 watt. And remember, the power you see now here in the upper right section is the average power. It is not RPP, right? So let's go on and let's check it. So as you see, it is switching into transmit, and now audio, audio, and you see it is working perfect. So what we can say is radio is working. Okay, so our radio is back together and work is done. Radio is full functional. So we are at the end of our video. Thanks for watching and catch you next time.